Alright, so in this video, we're going to do questions 8 and 9, and we want to find the mode for question 2, and then find the mean for question 4. It says to find the mean, find the midpoint of each class, and use it as an approximation for the raw data value. Okay, let's go back to question 2. And if we go back to question 2, we realize that we created a categorical frequency distribution. Now, the mode is the data value with the highest frequency. So in this case, if I ask you what is the mode of this categorical frequency distribution for question number 2, the answer will be O. Why O? Because O has the highest frequency. O has 9 values. There are 9 volunteers with type O blood. So to answer question number 8, the mode is going to be type O blood. Remember, the mode is the class with the highest frequency. Now, number 9 wants us to find the mean for question 4. To find the mean, find the midpoint, right? So if we go back to question number 4. Question number 4, we created a grouped frequency distribution. And I'm going to write down, and I'm going to redraw that same grouped frequency distribution down below. Let's scroll down. Okay. Alright, so it looks way nicer here than it did back up in question number 4. So, to find the mean of a group frequency distribution, we're going to need to find the midpoint. I'm going to create another column, and we're going to call that column midpoint. And we're going to symbolize the midpoint as x of m. And the reason why we want to find the midpoints for each class is because in a grouped frequency distribution, we know we have 3 values between 100 and 104, but we don't know the exact values it is. Well, at least not in this form. All the values could be 100, they could be 104s, they could be a mixture of numbers between 100 and 104. So we have to approximate, and we approximate by finding the midpoint of the class. To find the midpoint of a class, which I'm going to write the formula below, it is going to be the lower limit plus the upper limit divided by 2. So I want to find the first midpoint, x of m1. So that's going to be 100 plus 104 divided by 2. 100 plus 104 is 204. 204 divided by 2 is 102. And that's going to be the first midpoint. You're going to do the same thing for the next class. 105 plus 109 divided by 2. 214 divided by 2 is 107. I'll do it for one more class, and then I will show you the pattern. The midpoint for class 3. 110 plus 114 divided by 2. 224 divided by 2 is 112. If you notice the pattern, as I find each midpoint, they are increasing by 5. 102 plus 5 is 107. 107 plus 5 is 112. Which means if I add 5 again, we're going to have a midpoint of 117. Add 5 again, 122. Add 5 again, 127. Add 5 again, 132. And let's not forget, when we did this problem back in chapter 11, section 1, the width, which is known as the distance between each class, was 5 units. Remember, the width is 5. So that means the midpoints will also increase by the width for every class. Alright, let's continue. Now, we're not done yet, because we're now using the midpoints for our values. So we're no longer looking at the limits. The limits are no longer of any concern as of right now. The frequency lets me know how many of those midpoints do I have. In this case, I have 3 midpoints of 102. I have 8 midpoints of 107. I have 16 midpoints of 112. Remember, to find the mean, I must add the numbers and divide by how many numbers in total. So I can add 102 3 times to get 306. But I can use the shortcut to addition, which is multiplication. So I can multiply each frequency by the midpoint. So I'm going to create another column called f times x of m, where f is the frequency, x of m is the midpoint. So now we can multiply the 3 times 102. 3 times 102 is 306. We can multiply the 8 times the 107, and that's going to be 856. We're going to multiply 16 and 112, 13 and 117, 7 and 122, 2 and 127, and 1 and 132. So I'm going to multiply the numbers that I know. So 1 times 132 is 132. 2 times 127 is 254. 7 times 122 is 854. Let's do 13 times 117 in the calculator. That is going to be 1,521. And 16 times 112, 1,792. Alright. Now remember, multiplication is a shortcut for addition. After I do that, after I multiply my frequencies times my midpoints, I want to add those values. Therefore, I want to find the sum of my frequency times my midpoint. So now I'm going to add 306 with 856. 1,792, 1,521, 854, 254, and 132. And that equals to 5,715. So when we add up all the values, we get 5,715. Our last step is we're going to take the sum of all our values and divide it by our total frequency. And the total frequency in this case is going to be 50. Because if I add up all those values, I get a total of 50. So take the 5,715 divided by 50. 5715 divided by 50. And that equals to 114.3 degrees Fahrenheit. That is the average highest temperature of the states. Now, there's a formula, right? The mean. When I calculated it, right, it equals to the sum of the frequency times the midpoint divided by the total sample size. And that is the mean formula for grouped data. Alright guys, that is it to this video. And that is it to Chapter 11, Section 3. We're now going to transition on into Chapter 11, Section 4, where we focus on the measures of variation, which is just as important to statistics as the measure of averages. I'll see you soon.